Hello, RAP students. This is Dr. Smith. I'm here with you today. Today we're going to do a chemical experiment. We're going to figure out if different products are acids or bases. So what I'm going to do is I'll get started with the experiment first, and then we'll talk about exactly what happened, all right? So how we're going to start is I'm going to use some cabbage juice. I know that sounds weird, but there are plant dyes that actually react with different acids and bases, and they create color changes. So what we're going to do is take cabbage juice, because hopefully when you do experiments, you're not trying to go out and buy a whole bunch of expensive equipment at this point. You're going to just use what you have at home. If you don't have cabbage at home, that's fine. You can always buy cabbage. They're not extremely expensive. And you can always eat what you don't use. I mean, you could eat what you use too, but that's up to you. So how you make the cabbage juice is if you want to get a small cabbage, some people use half the cabbage. You can decide how much you want to use. I took some of the outer leaves of the cabbage and mixed it with, I shredded it, and I put it with a cup of water in a pot, and I boiled it for 10 minutes. And you'll come up with some purple looking juice like this, and you wait for it to cool, and then you strain it. You can use a strainer or whatever, just drain the juice off, and then you'll have your cabbage juice. So I'm going to take the cabbage juice and I'm going to pour it into each little glass bowl here. Now I'm going to then take things like, I have some apple cider vinegar, so I'll probably put it right here in this one because we need something like that. And then I'm going to put milk in this one. That's milk right there. I just took a little bit. And then I'm going to do baking soda. This is the baking soda, but I just put it in another container here. I'm going to mix, pour each one in after the cabbage juice. And we're going to see what kind of chemical change we're going to get, if we get one at all. So at this point, it's supposed to be an experiment, and you don't know. So the color changes I'm looking for are pink and green. Pink will tell us, if the color changes to pink, that it's an acid, and if it changes to green, it's a base. So just so you keep that in mind. And if there's no change, that means it's neutral at this time. All right? So let me go ahead and get started. Kind of push these back. Oh, and let me say before I start, you notice to have on a coat. It's good to have a lab coat to protect your clothing and yourself. If you don't have one, today we are using things that you can find in your kitchen, so you can always use an apron. And you need to have, when you're doing chemical experiments, safety goggles. And because we're doing things with substances that you have in your kitchen, I'm just going to wear my glasses. But usually, if it's true chemicals, you need to have on goggles. Even people with glasses, they have goggles that you can put over your glasses, okay? So if you have goggles, go ahead and put them on and get into the practice. Now just remember, this is cabbage juice, so it smells like cabbage, okay? I'm going to use my tablespoon measuring spoon. You do what you want to do as far as putting it in here. That helps me keep everything kind of the same for all of them. I'm going to put about a tablespoon and a half in each one. So now, just make sure that anytime you're doing these experiments, that you clean whatever measuring tools or anything that you're using throughout the experiment, because it could cause a problem with your reaction if you have some substances left on there. So we're going to start with the apple cider vinegar. You can use regular vinegar too. Do a little bit more. You can even use lemon juice. If you don't have any kind of vinegar, you can also use lemon juice. That'll work just fine. Let me clean this off. I'm going to dip it in some water here. So maybe that will help me out there. And now, let's do some milk. And last but not least, the baking soda. I'm going to swirl my baking soda around just because it's more of a solid, not a liquid. It's still sitting in the bottom of there. I think I'm going to use a little straw to kind of stir it a little bit just to see how much of a color change. Okay. Now we have to figure out what's an acid and what's a base. So if we look at the end product here, what color is that? That is pink to me, some sort of pink. So if we look up at our little note we made, it's pink, so that means that the vinegar is an acid. And let's look at the next one. That one's a shade of blue. So it's neither, if we look at our note, it's neither pink nor green. So if I had to choose, I would go with no change, because it's still blue. And it's neutral. At least that's what our experiment is telling us. And the last one, even after you swirl it around and stir it, it ends up still being the same color, which is like a bluish green. So I'll say it's in the green family. And so that means, according to our notes, that it is a base. So baking soda is a base, according to our experiment. Now, I'm going to go ahead and put up the reaction that just happened, okay? Well, let's talk about the first one, which was vinegar, and let's talk about baking soda, because these are our acids and bases. So since this is my first presentation on acids and base, or even any kind of chemical reaction, there's certain small things I want you to know as we continue. So I'm going to write the chemical formula for what's called acetic acid up. It's like a general name for vinegar. I'm going to write it up here for you so you can see it. so you can get used to seeing things like this when you're doing chemical reactions. And then I'm going to write one for baking soda. Now, so the first thing is, you're probably thinking, what the heck does that mean? So if you aren't familiar with the elements, we first have to get you familiar with the elements. So you see up here different letters, such as C, H, O, and Na. Okay, on what's called the, let's put it over here, periodic table, we have these different elements here. Now, the symbol C actually represents an element, carbon. So whenever you see C, it's going to be carbon. And the capital H will stand for hydrogen. And the O, capital O, stands for the element oxygen. And Na, this is one element, if you'll notice that it's not capital N, capital A, because that could cause some confusion, because with elements, they are capital letter. If there's two letters for the symbol, only the first letter is capital. So that's why you see the lowercase a here up top, because that's one element. When you see lowercase letters, that means it goes with a capital letter, okay? But this one stands for sodium, so they're nothing alike. They look nothing alike. The others did because you have an O here, H here, and a C here. But sodium, it has a lot to do with the origin of the word, okay? That's where that came from. So what I need for you to do is to learn these elements so that when you see them written like this, even if it's a complicated chemical name or whatever, if you can still do something with this. You say, oh, well, I know this is carbon, hydrogen, carbon, oxygen, oxygen, hydrogen. That's a good place to start, okay? Knowing some of the elements, that's good. That's very good. So one way that you can remember some of these is if you actually know that water is called H2O, that means hydrogen. There's two hydrogens and an oxygen. So you were learning something before you even tried. If you knew that this was H2O, water was H2O. Yes, you knew something already. That's hydrogen and that's oxygen. And another one would be carbon dioxide. So if you know what carbon is, like here, carbon is actually CO2. The di means two, actually. And then oxide. So now you know a little bit about how these are written and what some of them mean. But we're not going to go in extreme detail. And so vinegar, as we have learned from our experiment, is an acid. And baking soda is a base. So this is how we know the difference between acids and bases, other than the experiment and color changes. So I'm going to do a little not necessarily a chart, but kind of give them each their own side here. Okay, so if any of you know what vinegar tastes like, it's sour tasting. So it makes sense that that's the acid, because acids taste sour. And the other thing is that acids can actually conduct electricity. And hopefully you'll get to see an experiment, if not with me, with someone else, using lemons. We'll talk a little bit more about that. The other things is that acids can react with metals, and bases. Let's do taste. Taste, bitter. They absorb fats and oils. And a lot of times that'll be things like your household soaps, things like that. So household soaps, usually just think about, even when you wash your hands, a lot of times they're slippery. So they can feel slippery. Now, acids tend to have a very low pH, and you are thinking, what the heck is a pH? Well, it's a way that you talk about the different hydrogen ions that different substances have. So I'm going to put hydrogen right here. So the more positive ions you have, the lower your pH. pH goes from 0 to 14. And if you're in the middle, of course that's 7. In the middle, you'll be neutral. So on this side, if you're the most acidic or have the most acid, you'll have a lot more of positive hydrogens, and it'll put you on this end of the scale. And if you're on this end of the scale, where the 14 is, you'll have the least amount of positive hydrogen ions, and so you'll be on the base end. If you're in the middle, then you're kind of in between both, and you're just neutral. So we would put our vinegar on this side. It has more hydrogen ions. And we would put our baking soda on that end, having less hydrogen ions. And our milk, because our milk wasn't even on the scale at all, we're going to have milk sit right about here. And so that means that your baking soda is on this side. And your vinegar is on this side. Another thing that's on this side is going to be something like lemons. Remember when I said if you didn't have any vinegar, any type of vinegar, you could use lemons, lemon juice. But apples are also on this side too. That's how apple cider vinegar is made. You need to have some apples to have apple cider vinegar. So this is kind of the simplified version of what we just did as far as knowing what acids and bases are. But we're going to get into that in another lesson, putting all of this together, okay? But if you would like to continue testing things at home, feel free to do so. Find different things, but get your parents' permission before you do it. not cleaners. You try not to do cleaners. Get your parents' permission so you can figure out what's an acid and what's a base. Just make sure if you get a big enough cabbage so that you can do it as much as you like, or if you have other children in the home that would like to do it too, and get your aprons, because this stuff, when it gets on things, that's a bit messy, but you may like that. Now, the other thing I wanted to point out, if you're just getting started on chemical reactions, this is a good place to start, and you might not have to pay anything. I mean, you could go to the dollar store and purchase some little materials if you like, but as you become more comfortable, or if you just want to start where you want to start, you can always get a chemistry set. I got this years ago when my son was younger. He's out of high school now. And you have to be at least 10 to use this, because unlike what we did here, these are actual chemicals. But it does come with a lab manual that shows you how to do all of these experiments, kind of like my lab manual. I have my own written one, but usually when you're in a lab, there's a manual that has all the instructions on what you should do. So this is very similar to what we did today. I think other than that those are chemicals that could actually harm you if you don't use them properly and without supervision. And you get to know some of the equipment in them. But if not, you can always stick with what you're doing here, okay? I hope everybody enjoyed that. I did, and I hope that you will join me again for more chemical experiments, because I'm going to tie this into another lesson. So in the meantime, go ahead and do your experiments, try some different things at home, and remember that it's important to exercise your mind as well as your body. And I look forward to talking to you soon.